Yes. Okay.
Just click on the other. If you want to share your screen,
Yes.
you can use that one. Otherwise, we need to upload it to a slide in the second one.
This one.
Yes.
Separate load slide.
Is this your slide there?
I hope it's the latest version. Can we check? No, I just sent you a version in the afternoon. You
Okay. Otherwise, you can share your screen.
let me maybe just to be. Or maybe I can check whether it's the latest
Or
version.
Stefan, you can simply forward the mail to Alex, and they can upload the deck.
It's already here, so we can start. Yes, it's my yes. Yes. So can I stand to talk or I must stay here?
No, we don't have a clicker.
Okay, so I simply sit here to present.
If you have a clicker, they can.
Or maybe let's just start because I don't know waste people's time. So good afternoon. Can you? No, I seem to have echo here.
Is your audio switched on? Maybe because if you're in microphone, click this icon. Okay, try to say something.
Can you folks hear me?
And then you can go back to the.
Well, I'm on full screen. I don't know why it's not full screen here.
So, sorry. You simply share the application. Okay, so stop sharing, and then go to presentation view, and you should now get back to Miteco. Yeah. And then you have to share your screen again, and select yes. Select you can either share your entire screen, or if you want to share a window, you should yes, window, click on that window. You should see this open a new window. So don't close this one. Leave that window's open.
Where do I
Go in
go?
presentation view. Stop sharing. Okay, stop sharing. Alt tab to get back to tap on the
How
host.
you maybe do
Can
it?
I touch you?
Yeah.
Just look here. This one. Share.
Okay.
Like this.
Okay, folks. Sorry for the delay. Thank you very much for coming to the host tech talk. This is Xipeng Xiao from Huawei. There are a million IPv6 talks, right? So I first want to answer the question why you should also listen to this one. The reason is that I think that most IPv6 talks are given by IPv6 supporters. And usually the IPv6 supporters only tell you the good thing about IPv6. And I think that what's unique in today's presentation is that we are going to talk about a lot of the challenges facing IPv6. And the reason why I feel that this is important and useful is that just like, nobody is perfect, no technology is perfect, every technology have certain problems. And in order to get all the people on board to deploy IPv6, we really need to acknowledge the challenges, certain challenges that's facing IPv6, document the challenges, and possibly provide a guideline. And I think that Eric Winker kind of like set a good example for us in RFC 1999, because RFC 1999 basically document all the IPv6 security issues and provide guidelines. This way, people feel more confidence that, IETF know all the issues and, they are solving it. This is actually, provide more confidence, not less confidence. So with that, I really want to say that we spent a lot of time presenting, preparing for this presentation, and a lot of people provided a lot of, either statistics or provide a lot of review. And the list is long. And here I really, again, want to thank Eric Winker because he provided a lot of, very detailed feedbacks. So the first part is the momentum. While this is both for the IPv6 supporters and the IPv6 deniers, and by IPv6 denier, I really have no disrespect, just an easier name to refer to the camp. I know that the IPv6, for example, in the NANOC mailing list, there was a big debate this month about IPv6, and some people are complaining that IPv6 is not easy to deploy. There's no end user demand, etc. While we acknowledge that later, here we want to say that, for many of these, are you aware of the IPv6 progress in recent years? Because 10 years ago, if you are questioning IPv6, you are more or less justified, because at that time, there's almost zero IPv6 users. But now, according to this Google stats, we already have 36% IPv6 users. Some people argue that actually, due to the way Google count the users, many IPv6 users in China are actually mixed. So if you count also the users in China, it could be as high as 45% based on ETSI study. But while IPv6 grow very fast, it's very uneven, and this will have a major implication later that we will talk about. So what's driving this IPv6 momentum? According to Jeff Houston, this is, the GDP per capita, rich countries usually are more enthusiastic in doing IPv6. The user growth like reliance, and then IPv4 shortage, and also the competition. But it's not just this. It's not just this. And here we would like to offer our perspective, other, strong momentum on IPv6. The first one is that we believe that the readiness of IPv6 value chain is something very important, because the UEs, the network and the application train is finally ready. Because 10 years ago, if some of these, the content are not ready, then even if operator deploy IPv6, you are not going to get much benefit. But now it's very different. And here we list some of the major milestones, but the slide is busy, so you don't need to read that. All I want you to know is that it's summarized in these two blue bars. By 2011, IETF largely get the solution ready. By 2017, the UEs and the big application like Google, Netflix are all ready. And this year, we believe that there is another important milestone that many people may not realize yet, is the public cloud support of IPv6, like Azure and AWS. These are important. We will talk about why this may be quite significant. And then on the value chain, we are seeing that the network is still slightly behind the UE and the content. And if you are interested, I will not go into detail. If you are interested, later we can discuss why the network is 42%, how we computed that, etc. Another point is that I don't know whether the IPv6 denier realized that the price of IPv4 is going up so quickly. And specifically, the price doubled last year. And if you count it from 2014, it already increased 7 times. So if you dwell on IPv4, you may have to spend a lot more money if you have to buy IPv4 address. Or for some operator, they are even considering, going to IPv6 quickly. And while IPv4, price is very high, they can sell their IPv4 address. This is important one. And then the public IPv6, this is the kind of the other momentum that we saw. One is this, just now we mentioned the AWS Azure's support of IPv6. Why we believe that this is maybe very important. When we look at the operators, the big operating systems, the small and medium enterprise, we find that small and medium enterprise have the least motivation to move to IPv6. Because they have a very, they don't need many address, and also they may not have the technical expertise to make the move. So usually, if we look at the SME, there's a huge number of SME, they are simply in IPv4. But we believe that when these, AWS, Azure, when they support IPv6 and as the, SME go to the cloud, AWS may enable them to move to IPv6 very quickly. In the past, they may have to do a lot of work themselves. But now they simply select IPv4 or IPv6, and if they select IPv6, they go IPv6. So we may, today in the V6 Ops working group, there's a discussion, how to move the SME, and we believe that this may be a very big momentum. And then on the IoT, you probably see the number already. There's a lot of IoT device. And then 5G bring new bio and new opportunity. And then obviously there's these innovations on top of IPv6, like SRv6 and other things for provide better traffic engineering, network programming, etc. So for the people who don't believe in IPv6, I think that we really want to, these are some of the recent progress. Not to mention for example, the big government push, US government is pushing towards IPv6. Chinese government is pushing, but I guess maybe IETF people don't want government regulation, so I avoid them here. And the second part, I think that the first part is more to the IPv6 deniers. And the second part is more to the IPv6 supporters. And here, what we want to say is that for the IPv6 supporters, there really are more challenges than you think, because we as the supporter, sometimes we feel that our work, IETF work is done. these people are not doing IPv6 just because of the lack of the motivation, or because they are saying all kinds of excuses. I am completely ready. And what I want to say here is that, yeah, we are quite ready, but not completely. And let's see. So first, this is a survey from every NIC. It's done in 2017. You can say that, oh, 2017 may be too old, but actually, based on what I hear from other industry forums, if I compare it to some of the IPv6 challenges in December last year, it didn't change that much. And really, here, I think that it may be difficult for you to see all the things, but I just want to kind of like quickly classify them into 4 categories. One is motivation. I think that for IPv6, this like motivation is always one of the biggest issue. Okay, my end user don't care about IPv6. It's a lot of work, so why should I? So things like this. And then knowledge is also a big part. Okay, I don't understand IPv6. There are so many new protocols. That's difficult. So I think that the big part. Ecosystem is the value chain that we talk about. The UEs, does my CPE support IPv6, and the network, the routers, etc. And then technology is what's closely related to IETF that we will focus on today. So regarding this motivation, knowledge, I think that, this slide look a little deeper. I think that maybe we focus on the more technical part is the technology. So that the legacy device, there's the IPv6, the network management system. I think generally this is a field that, IPv6 network management compared to IPv4. I think that, there's still some work to do. And the OAM also maybe not as mature. These are some of the, common complaints from the field. But we want to say that, yes, these are issues, but, the industry largely, taking action to deal with them. So regarding the motivation and knowledge, leading operators are sharing their experience. And then, there's many IPv6 forums, councils. I think as far as I know, the UK IPv6 Council is especially, active, and they're doing a lot of good work. And then for the ecosystem, I think that we should really thank, Google, Amazon, I think Microsoft, they really did a lot of work. Apple, they really did a lot of work to move the industry towards IPv6. And for the last part, we are going to talk about the technical challenge. I think that it's the focus of our presentation today. So before we talk about the bad things, first let's say that IETF has done a lot. So this is not to complain. This is not to complain. But even though that we have done a lot, I think that there are remaining challenges. So the first one, I think that to compare the IPv6 performance versus IPv4 may be very relevant and more telling, because between IPv6 and IPv4, there are so many things that you can compare. For example, neighbor discovery is very different from ARP, but we believe that performance is really the very important, or maybe the most important KPI. So the first one is regarding the round trip time, the latency. So as you can see here, over the years, the IPv6 round trip time is constantly improving. But today it's still 2.5 milliseconds higher than IPv4. But this is world average. Later I will provide kind of like the grain of salt on my own this data. And again, this is based on Jeff Houston's statistics in APNICS. There are in the industry there are some other statistics like Vinker.org have some statistics, RIPE NCC have statistics, etc. But or at least I personally believe that maybe APNIC's data is more systematic. So I think that first is that, IPv6 and IPv4 is very, very close, but it's slightly higher on a worldwide average scale. So I think the very good question to ask here is that what are the top 3 factors leading to this improvement? Why, over the years, why this is improving? And if we understand what are contributing to this improvement, then I think that, we can provide a guideline for other operators that, do this from day one. Then, you can avoid certain things. So this is the logic time. The second one is the packet loss rate. And we find that the data here is really inconclusive. We provide, 2 data points here. The first one is from this Hindavi. It report that IPv6 PLR actually lower than IPv4. And this is, they did the measurement based on 1 week of measurement from China. And it says that, for them, they find out that IPv6 packet loss rate is 0.25%. For IPv4, it's 0.33%. So IPv6 performs slightly better. They also have some, distribution showing that Asia is much better, is or clearly better IPv6 than IPv4. And for other regions, they are more or less similar. And then we also, that's one data point on one angle. And then on the right-hand side, we are seeing kind of like a different result. So here we are citing, RFC 7872 by Fernando, by Jane Linkova here. Now I think recently Eric Vinker also have the so-called GEMS, talking about some new measurement on these extension headers. But the long story short, the result is that, in 2017, the packet loss rate for the packet with fragmentation is extremely high, 21%. And even last year, it's still 8%. It improves a lot, but it's still very high. Because we heard from many operators, that their IPv4 packet loss rate, or their packet loss rate, is about 0.1%, and we take it as IPv4 because most traffic is still IPv4. But there's really, I think that we find in the industry, but there is no data on IPv6 packet loss rate, or at least APNIC didn't provide it. We find, but we didn't find it. So if anybody have this data, we would love to hear from you. So if we take it from the first study at 0.5%, then IPv6 is higher than IPv4. But again, this is inconclusive. We don't know how much of this overall packet loss rate is coming from those fragmentation, extension headers, etc. We believe that this would be something good to find out. We really feel that, if we can dig into this and find out why, IPv6 is losing packet, etc., again, this would help to improve the performance and make the life of those deployers a little easier. And the third one is the TCP failure rate. Again, we can see that the blue one, the green one is IPv6, and then the other is v4. We can see that over time, the IPv6 TCP failure rate is again constantly improving. But I think that based on the data today, APNIC, it's still 0.96%. And IPv4, depending on how you look at it, it may be 0.25%, or some people, Jeff Houston, said that, it's almost 0%. So, IPv4 is almost successful. But anyhow, I think that the conclusion is the same. TCP failure rate, IPv6 is higher. So the question is that, is it because of the higher packet loss rate of IPv6? I think that this will certainly, if you have a higher IPv6 PLR, it's quite likely that the TCP failure rate will also be higher. And then, because QUIC is using more and more, in addition to measuring TCP failure rates, we also be measuring QUIC as well. So I think that these are some of the good questions. Okay, me as a supporter, IPv6 supporter, talking about IPv6 challenges here. And some people say that, oh, then there may be concern that, okay, I come to the conclusion that we shouldn't do IPv6. And I want to tell you that this is not the case, because again, just now what we're presenting is the worldwide average. A worldwide average can, the average can hide a lot of things, And if we look at the data, more carefully, we will see that, the world average can be dragged down by a region badly. And again, this is the same stats from APNIC. You'll see that, the whole world, the RTT of IPv6 is slightly higher, but it's largely, because of, Oceania. And if you look at the world, American and Europe, actually, IPv6 perform better than IPv4. So I really feel that these data are useful for communicating with the IPv6 deniers. When they say that, oh, it's bad, you have the stats to tell them what if you look deeper, what's the case. And also there are reports that IPv6 can perform better in enterprises. For example, we provide two references here. Apple at one place is claiming that, IPv6 can be, 40% better in the data center. Again, we provided the reference here. You can check out. And Facebook is also very enthusiastic in promoting IPv6. So I think the point here, our real point here is that IPv6 can perform better than IPv4 if you have a lot of talent, if you can do it, correctly. But it's not always easy. This is like a complicated machine, and if you install it, correctly, you operate it correctly, then it performs better than IPv4. But because it's due to its complexity, you may make mistakes, and if you make mistakes, then it don't work that well. So I think that this is the caution that we want to provide. As a consequence, I think that this is also another thing that I find as a big surprise to me last year. It may actually be a big surprise to many IPv6 veterans, is that many operators, IPv6 deployment are actually in overlay. And in the underlay, in the router, etc., they're actually tunneling IPv6 in MPLS, etc. So, when an operator tell you that, oh, I do dual stack, you think that, their routers are transporting IPv6 traffic natively. You think that their underlay is also dual stack, but that may not be the case. This is a big surprise for me last year. So first of all, let me clarify what's overlay and what's underlay. I think that this is a notion. It's applicable to operators and to some extent also applicable to data center, but it's not applicable for enterprise. If you are not providing a service to other people, you really don't have this distinction between overlay and underlay. But anyhow, for operator, overlay is the service layer, and it involves the user device and also the mobile gateway, your BNG or etc. This is your kind of like your service layer. And then underlay is your routers, etc. Is the to send the packet. Because IPv6 is, I think that the number one reason is to address this address shortage, to provide enough address. And if to do that, then IPv6 at the overlay is sufficient. And why operator don't want to, many operators don't do native IPv6 packet transport is because if your router is dual stack, really dual stack, then you need a control plane, management plane, data plane for IPv4. You need a separate plane for IPv6. However, if you just tunnel IPv6 packet inside IPv4, then you only need a single, data and control and management plane. So many operators feel that, okay, actually it will be easier for me to maintain just one per plane than two separate planes. And there are many of them are using 6PE, etc. So some of the IPv6 veterans thought that operators IPv6 is largely done, but this is really not the case. First, there are many big operators still doing IPv4. And even for those already deployed IPv6, their IPv6 may still just in the overlay, not much in the underlay. So this is, again, back to the question that we need to make IPv6 perform better. We need to identify the challenges and make IPv6 perform better than IPv4. Otherwise, there are still a big part of operator network can remain in IPv4, and there are many consequences. So here, how to make IPv6 perform better than IPv4? There are these answers. The first two came from Jeff Houston. The first 2 points came from Jeff Houston. He actually have 3 points, but I had to delete 1 point because that point received a lot of protest. The deleted point is that he said that you should avoid stateful IPv4 to IPv6 transition, and that would kind of like exclude, for example, 464 XLAB, etc. I received a lot of protest from that point, so in the end I delete it. There are other points. The next 5 points, below the white space, the other 6 points are the 5 points are based on our analysis. First is move content closer to end user. This will improve both IPv4 performance and IPv6 performance. But there are data showing that the improvement for IPv6 is actually bigger than for IPv4. So it close the gap or even change the winner. There are some explanation, but we don't have the time to go into detail why this is the case. Increase link MTU if you can, and choose the TCP MSS. These are all to trying to avoid fragmentation, because fragmentation, if it happens, it will cause very high packet loss rate. And then there's this like announcing IPv6 route and route filtering. Jeff Houston provided some example that, if you don't do it, he basically provide one example that between Australia and Singapore, IPv4 is Australia to Singapore and directly back to Australia. But for IPv6, packet go from Australia to Singapore to Germany to US and then back to Australia. And then obviously you are going to have a lot higher round trip delay and possibly packet loss. And then there's this packet filtering. I would say that here we provide some references, but more work probably need to be done, or at least we should discuss and document these challenges, and then provide a guideline on all of these. What can make IPv6 better. So this is the second part, and the third part is looking forward. As we said, if you look at the world average, it seems that IPv6 seems to be a little worse. But if you look at deeper, actually, as we say, if you do IPv6 correctly, IPv6 can perform better than IPv4, just like in America and in Europe. So if we look at the world today, I know that this is a busy slide and you will not be able to tell the company or read the small numbers. I think that there are only 2 impressions that I want you to get from this slide. First is that there are many companies with very high IPv6 user percentage already. Starting from the, the top one is 100% IPv6, and even the bottom one is still like 57%. It's still 57%. As we said, these are companies that do IPv6 correctly and benefit from it. They can already move to IPv6 only. They can already move to IPv6 only. Brian Carpenter told me that, every time you talk about IPv6 only, you should immediately say that IPv4 as a service over IPv6, because otherwise people will say that, oh, this guy is a radical. How can you be, IPv4 will stay for many years. They thought that IPv6 only means that no IPv4, but it's not the case. It just means that, IPv4 will be run as a service over IPv6, but it will disappear from the infrastructure layer. So it's the time to do so. And here, will be a little bit more specific. So at least from an operator perspective, Facebook already done it. I think that the hyperscale have a lot of talent. They probably have, the best talent in the industry, and they have no problem. They can do whatever. But for some operators, it may not be so clear. So we kind of like, draw some picture. I think that the mobile one, we kind of like use 464X lot as an example. And the first one is a little bit like, quite this light, or, one of those solutions. But the real difference is that I think that IPv6 only at the moment in the industry, for some people, it just means the IPv4 as a service. Again, it's just in the overlay. And here we want to make sure that, by IPv6 only, we not only mean overlay, we really mean, underlay. And the IPv4 packet will be tunneling inside IPv6, We believe that this will further improve the performance of IPv6 and make it better than IPv4. So this is largely the kind of like the last slide before summary, is that the difference between this one and the IPv6 overlay is that we believe that, if you do the today's way, IPv6 overlay plus IPv4 underlay, you are basically, you have no exit strategy, because your underlay is stuck. Even though that your IPv6 traffic is increasing, but you don't change your underlay, and you always have two protocols. But if you tunnel your IPv6 traffic, IPv4 over IPv6, because IPv4 is becoming a smaller and smaller percentage, then one day you can finally just purely IPv6. And really, this requires solving some of the challenges that we talk about in this presentation. Really, we need the help of IETF and the leading operators. We really need, first, we need to document all the challenges and provide guidelines. So this brings me to the summary. Again, we want to emphasize our feelings that it's like a sophisticated machine. Only if you can install and operate it well, it will be better than IPv4. Otherwise, it can be worse than IPv4. And in this aspect, we really need IETF to kind of like provide kind of like better user guideline to make sure that people will have a higher chance of install and operate it correctly. This, if we do this, then we can accelerate the move to IPv6 and IPv6 only. And here we specifically list some topics that we hope to get your contribution. I will pause here and let you a few seconds to read it. I also provide my contact information, so we love to hear from you. Thank you very much. I think you don't usually get applause, in a IETF, so I feel really honored. Any questions, comments?
I cut in front of you last time. You go ahead.
I'm not even the first in the queue. Whoever the first.
So, Rajiv, do you want to speak?
I hope you guys can hear me. So I have
Yes.
a question, Shipeng. You talked about there having been some work done to measure the performance improvement, and that performance improvement for IPv6 being larger than the performance improvement for IPv4 when you talk about dealing with deep edge or deep in the network deployed content. So I was just wondering if you have any study or reference material that I can look at, because that is an area of great interest for me and the organization that I work for, and we'd love to. We're already kind of semi-dual stack, but we deploy in a lot of networks which are still to this day large, consumer-facing ISPs that are IPv4 only. So we'd love to be able to show some statistics and try to help move the needle with these mid-sized ISPs who have just not got onto the IPv6 bandwagon yet.
Okay, I think that we should probably take this discussion offline because one is it will take a lot of time, and second, I cannot remember all the the reference, so I can send you the reference afterwards.
I will definitely email you and we'll take this up offline. But then this is a very interesting data point to have, because we as service providers who are going into these deep network locations, we would love to have some ammunition so that when we go to these providers who are reluctant to embrace IPv6, we have something that we can show them and say, hey, it's in your interest to do this, even though you may not see a pressing commercial need to do it right now, but hey, here's a case for a performance improvement for your customers that should help you make the decision to go ahead and do this.
Okay, thank you, Rajiv.
John Linkover, Google. As an enterprise operator who spent some time operating dual stack and V6 only network, I have an impression that in my experience, every single case when you see V6 performing worse than V4 is because of happy eyeballs. Because V6 network is broken, nobody monitoring it, because of happy eyeballs, users are not complaining, and it stays like that until you turn off IPv4. So I'm quite sure it's not something in the protocol, not something in the connectivity, it's just bad operational practices.
Okay, yes, I think that's kind of what we are saying. That the machine itself is fine, but if you don't operate it correctly, then it has problems. Barry.
Hi, this is Barry Lieba. Can you go back to the slide where you show the performance differences in different regions? And I'm curious on that. Yeah, you just passed it. No, go back the other way. Next one. That one. Do you have any sense of why Oceania is so bad compared with the other regions?
I don't.
Okay.
Because I think that this is a slide that I newly add, and I today I went to the APNIC data and copy this. I think that it's a good question that we can probably discuss together with Jeff Houston.
Okay, thanks.
Hi, Mike Ackerman. First off, I want to say that you covered a lot of information. This is really good stuff. I hope you'll come back and do it again. It's almost inspirational.
Thank you.
The first question I want to ask, maybe somebody already did. Can we get copies of your slides?
Yes.
Fantastic. And then I just wanted to ask one specific question. I got your email. I got a whole bunch more, so beware. You had a slide that said, and it's right up there. It's that IPv6 performs better in enterprises. I'm one of those. Is there a short answer as to why or how?
We see it in this. For example, let me take Facebook as an example. Facebook, we provide here. It's a link to a YouTube video. And in this YouTube video, I believe that the person's name is Todd. Well, it's a Facebook person talking about IPv6. His IPv6 performance is better than IPv4. I remember it's in a nano meeting or in some kind of meeting. And then there are people from the audience ask the same question that you just asked.
Yeah, we want to know
and
that
then
secret.
Those people, I think that they provide some kind of. I will not say that it's very direct answer. They say that, well, for example, if you do IPv6, then you have no net. But really, net will introduce only a very small difference. So IPv6 is better. Is it really because of net or because of some other reasons? We didn't get a very clear answer from that YouTube video. I think we have the reference here.
Yeah,
you can take a look yourself.
I was hoping there was some great generic answer, but it could be application or situational specific, and that's certainly understandable. But
yes, we really, I think that these are the questions that we should dig into, and this is why we are doing this. And actually, maybe Jane also have some comments. Do you, for example, in your Google network, do you feel that IPv6 perform better, or if it performs better, why?
I definitely wrote down what she just said, that when you get to IPv6 only, and that makes a lot of sense. You can see where the economies of scale will start to add up and give you better performance, maybe even holistically. So I'm just looking for any answers anywhere I can get it, and this was great. Thank you again.
Thank you. So we are already 5:30, and if there are no more questions, I really want to. Rajiv, you have another question?
One very quick question, if it's not too late.
Go ahead.
Rajiv here.
Go ahead, Rajiv.
Yeah, so this is again relating to the difference. So while in this table, you're kind of showing the average difference in the RTTs. And yes, based on these numbers, Oceania looks like it's a massive outlier with a much larger average. But I probably am not as surprised by that, because it's quite likely that the overall total RTT average for connections in Oceania are probably going to be a whole lot higher, because of the fact that it has very limited capabilities of serving traffic locally, and most traffic originating from there is reaching out to some other region of the world in order to get served, which is not the case with maybe Americas or Europe, or for that matter even Asia, because a lot of that traffic will be within the region. Okay, so
yes.
a lot of Asia is going to be served out of China or India or Singapore, and doesn't really have to go outside the region. So when the total connection RTTs are, say, in the range of 40 or 50 milliseconds, say a 10% difference turns out to be 4 milliseconds. Perfect. So with Oceania, if the average of their connections are mostly going to be in the 300 and 400 millisecond RTT range, because they're all going outside of the Oceania region to get served, a 10% differential in performance would still look like a very big difference over here. So my question is, have you looked at that as a data point while doing this analysis?
The short answer is no. As I said, this slide I added today, upon the request of a colleague. But I can offer a observation. is that, if you know Jeff Houston, how he collected statistics, he's basically partnering with Google and, putting a kind of like an ad on the, Chrome browser, and then this Chrome browser will contact his prober, let's say, and then because this is sampling, so I do the observation that, at different time, these can, for example, tomorrow, if you go to, Jeff Houston's side and then take another snapshot, the number can be quite different. So I think that this is point number one. This you definitely cannot, draw a conclusion that, Oceania is always bad. So again, all of these, average statistics, you must also look at it from, kind of like take it with a grain of salt, salt. Really tomorrow when we look at the one, and just now when you talk about the maybe, Oceania is far away from content, but again, we are talking about the difference between IPv4 and IPv6. And the long distance, is a burden for both IPv4 and IPv6. So arguably, it shouldn't create a lot of difference. But other than that, really, I'm sorry, I really feel that for IPv6 performance, there are a lot of analysis is worth doing, because we really, know, I would say that we know very little. And if we just support IPv6 and we don't face these challenges, then will not just go away. So I think that this is why, I like to do this talk and kind of like expose these challenges, and so that, we can, do something together.
Thank you. That was very informative.
Well, let me thank all of you very much for spending the afternoon with us. I really appreciate it. And you got my contact information, and we really love to hear from you. So again, bye now. That was very interesting. Thank you so much. It's very